In this lesson, we're going to identify polynomial functions and to understand the relationships between the degree and turning points. The graph of a polynomial function can actually be determined by the function's degree. Now that degree can be either odd or even. In the polynomial function given below, notice that out of all the degrees, the highest degree of this polynomial is a degree of 4, and 4 is an even number, so therefore this would be a graph of an even function. Also, its leading coefficient will also tell you some things about that graph. Now, the leading coefficient is the coefficient of the greatest degree in the polynomial. So again, 4 out of all degrees, 4 is the greatest degree. The coefficient of that term is a 2. So that whole term there itself, 2x to the 4th power, that is considered your leading coefficient. And notice in this case, the leading coefficient is positive. So that's going to also determine what that graph will look like. Just those two facts, its degree and leading coefficient, which we will discuss in an upcoming video on the end behavior of a graph. You may already be familiar with many of these polynomial functions and their degree, such as the constant function has a 0 degree, linear function 1 degree, quadratic, the highest degree is a 2, cubic function, the highest degree is a 3, quartic, degree of 4, quintic, a degree of 5. Polynomial functions often have turning points where the function changes from increasing to decreasing or vice versa. A polynomial function of degree n meaning out of all degrees the highest degree of that polynomial, has at most n minus 1 turning points. So in this particular given polynomial, out of all degrees, the highest degree is a degree of 3. So this polynomial has a degree of 3. So we can find the number of turning points by simply plugging in n minus 1. So removing the n, replace it with a 3. That will be 3 minus 1, which means that we will have 2 turning points on the graph. Notice the 2 turning points indicated. Without looking at the graph, how many turning points can you expect this polynomial to have? Well, first of all, you want to look at the degree of the polynomial. So the degree of the polynomial is 5. So if we calculate the turning points with n minus 1, that would be 5 minus 1, which means that we can expect it to have 4 turning points. And here they are. 1, 2, 3, and 4. Okay, that's it for this lesson. Thank you for watching MVP Tutorials by your instructor, Dr. Speights. I hope you'll join me in the next lesson. Please feel free to like, share, and subscribe. Goodbye for now.